Hello students, welcome all. So we are going to discuss the test paper which I have created on our platform. So this paper is quite a interesting paper where there are a lot of interesting questions are there which test your technical skills, right? So let us discuss this question paper one by one. Let's start with the first question. For the circuit below, identify the logic gate. So there is a logic gate given here. You need to, based on the circuit, you need to identify which is the logic gate. So this is A input, B as input, and then it is going here. Then this is output Y, and this is the resistor. This is ground, right? So what happens here, you can make the truth table also A, B, and whether the current will be flowing in this or not. So if this point Y becomes higher voltage, and if current passes through this, then there will be output. You can say that there will be current. There will be current. So let us take 0 0. So if I take 0 0 means this become lower voltage, that become higher voltage. So reverse bias, there cannot be any current. So you can take this as 0. Similarly, if I take any one as 0 and this is 1 or 0, then what will happen? Current will flow in any one of them. Suppose this is 1, this is 0. So no current in here, but current will flow from here and it will come here like that. So any of them 1 means we can choose, and if both of them are 1, then definitely it is 1. So you can clearly see that this output which is coming, it is nothing but the OR gate, right? It is nothing but the OR gate. So you can choose OR gate option, right? Second option. Let us move to the next question, number 2. Second question. What does it says? In a vernier caliper, 4 main scale divisions matches with 10 VSD, right? One main scale division is equal to 1 millimeter least count. See, this is a very fundamental question. Here most of the students have made mistakes. What is the reason? They simply apply the formula. A formula based knowledge is not going to help in JEE. Okay, it's not like a mug up things. Here you need to understand what is the meaning of least count. Let's understand little bit in depth about least count. So suppose according to this question, four main scale division is matching 10 vernier scale division. That means 2 main scale division matches with 5 vernier scale division. So let us try to draw this. This is main scale. Let's say this is main scale is 0, and this is 1, and this is 2, right? So 2 main scale division, and we want 5 vernier scale division. It is matching. So let us say that this is vernier scale division, and starting from 0, and we have to take as 5. Now note that uh, when you are going from here to here, so that means if you take 1 MSD, 1 MSD is near to 2.5, correct? So if I take this as 1 here, 1, this is nearly 2, this may be 2.5, then this may be 3, this may be 4, like this. Okay, like this it will be. Now try to understand what is called least count. Least count means, suppose I want to measure, so I need to little bit displace this one, right? I have to displace this vernier scale, so that in between the jaws of the vernier caliper we have to fit some object, right? So minimum measurement is what? So if I move little bit, so which division can coincide, that is what you need to see here. So if you try to move little bit, so which one can coincide? If you move, try to understand this. if you move this one towards right side little bit, so this 1 and 2 may coincide first, then possibility is also there that this 2 of the main scale can coincide with 4. So this is what will happen first. So try to find out what is the minimum division. That means the difference between this and this, and difference between whichever is minimum, that is the least count. And definitely you can understand the gap is increasing. So here gap is minimum. Here gap is minimum. So this, what is that minimum gap? That minimum gap is least count. So that means 1 MSD minus 2 VSD. This is what is least count here. 1 MSD is 1 millimeter. They have given 2 VSD. 2 VSD will be how much? Anyway, 2 VSD is 5. Yeah, 2 VSD you calculate. So 5 VSD is 2 MSD. So 1 VSD will be 2 by 5. 2 by 5 MSD means millimeter. Calculate this. How much it will be? Calculate. 1 minus, this is 4 by 5, right? 0.8. Then it will become 0.2 millimeter. Try to understand, and you should ask question why least count is always 1 MSD minus VSD, 1 VSD. Why? Because in that scale, this one least count is nothing but the difference between 1 MSD minus 1 VSD. I will show that diagram also. Try to understand this clearly. Suppose in normal scale, what happens? 9 MSD is equal to 10 VSD. Correct? If I draw that scale, let us draw that scale. So main scale division. So if I say main scale, this is 0 to 9. 0 to 9. Vernier scale, if I draw vernier scale, it is 0 to 10. 0 to 10. And if I want to draw divisions, let us draw divisions. So let's say that this is 1, 2, 3, 4, 5. So in between exactly 4.5 will come, right? So maybe 5 will be here, 6, 7, 8, 9 will be there, and here 1, 2, 3, 4, like this it will be there. What about this? This is 10 divisions. So note that this will be 1 will be coming little bit away from here. So little bit away, little bit larger it will be. Which is larger? This one main scale is larger than 1. So here 1 will come somewhere here. 1. Its 2 will come little bit like this. Sorry, 2. Then its 3 will come like this. Then its 4 will come like this. 5 will come like this. 6 will come like this. 7 will come like this. 8 will come like this. 9 will come like this. 10. So you have to note very important thing, very important thing. What is that? That this gap between 1 and 1, gap between 2 and 2, gap between 3 and 3, gap between 4 and 4. So this gap is increasing. This you have to understand first. The gap is increasing. Okay. Now, what is the minimum displacement that you can give to the vernier scale? The minimum displacement that you can give so that corresponding divisions matches, or any division will match. So if you move little bit, 1 will match. That is one case. 2 can also match if you move. If you move little bit larger displacement, 3 can match. If you give little bit more, 4 can match. So these divisions which can match, that is like the minimum measurement that you can do, right? So suppose 1 difference if you calculate, that is what is the normal least count formula which you calculate. Least count formula which you calculate is 1 MSD minus 1 VSD, right? That is 1 millimeter, and from here 0.9 millimeter, that's what is 0.1 millimeter. But note that this least count is true for this scale. Normally we can use safely this formula for certain conditions, because 1 gap, that is the least count. But in this case, in this question which I have given, there 1 division gap is not the least count. Okay, that's what you need to note here. Okay, So in this case, the minimum division is one main scale and second of vernier scale. That is the minimum measurement possible. That is what is least count. Clear? Very, very important and fundamental concept. Many people don't know about this. Okay, many people, because in textbook they don't mention it. In even the lab manual they don't mention it. Practical physics related topic it is, right? Let's move next. Question number 3. For a prism, they have given refractive index to cos A by 2, right? A is the angular prism, and minimum deviation condition, it is minimum deviation condition we know 2i minus A, right? That's the minimum deviation condition. Prism is used under minimum deviation condition without total internal reflection. Which of the following correct a range for prism angle? What should be the correct range for prism angle? So let's think about it. Suppose this is prism angle and you are giving a ray like this. Some angle of phi is there. Note that this is R1 or R2. They are going to be same, right? This will be coming like this. So this is E, which is same as psi, right? That's the condition for minimum deviation. Now we need to calculate what? We need to check the range of A. Range of A. And suppose if I consider here, and they are saying that total interreflection is not happening, right? Uh, Without total interreflection. So this angle R is not the critical angle. So what should be this angle R? Should it be less than or larger than? Definitely R has to be smaller than critical angle. This is the condition for no TIR, no total internal reflection, right? This is the condition. So sine, and what is R here? R is A by 2, we know that. So A by 2 is less than critical angle. A by 2 is less than critical angle. So here can we apply that? We can take sine R also. In terms of mu also we can take. Let us take sine A by 2. Sine A by 2 is sine of critical angle. Critical angle. Apply this condition. Then what is critical angle? Sine of critical angle is 1 by mu. So sine of A by 2 is less than 1 by mu. Correct? 1 by mu. And mu factor now you substitute. So from here sine of A by 2 is less than 1 by 2 cos A by 2. So from here you will make this as 2 sine theta cos theta, that means it becomes sine of A. Sine of A must be less than 1. So what condition can we get? Yes. What condition can we get? So we can get A must be less than 90 degree, right? And definitely A has to be greater than. Equality you can consider if you take extreme case. Total internal reflection is just going to happen or rays will gauge there. So you can go with the second option where angle A less than equal to 90 and greater than equal to 0. This will be the correct answer. You can go for this. Let us move to the next. Question number 4. Consider dielectric medium placed in electric field. Analyze the following statement. Gauss law. So suppose electric field is in dielectric medium. Gauss law. How do we consider Gauss law? Note that Gauss law, if you try to apply Gauss law, electric field dot dA vector is equal to charge enclosed by epsilon naught. Now in many textbook, this has not been very clearly given what is the effect. They have simply written that charge inside by epsilon, because medium is changing, then they say that epsilon naught become k times epsilon naught, right? But that statement is not 100% accurate, because there is a concept of polarization of the dielectric medium. I think you may be knowing about this. Suppose there is a electric field, right? Some external electric field, let us say E naught, and if there is a dielectric present, let us say there is a dielectric material is present here. So the dielectric will get some induced charges, right? This side it will minus induced charges will come, and that side plus induced charges, this side minus, okay, right? And the value of this induced charge is what? This is q, uh, 1 minus 1 by k. But generally we put a minus sign here to show that here negative charge is induced, that side positive charge is induced, right? And note that this q is nothing but the charge which is like a free charge. Suppose for example, if you put a capacitor, if you put plus q minus q, so that charge is the charge on the capacitor, and this medium which you are keeping here, this medium, this side, this surface of the medium develop that negative charges, and this surface of the medium develops this positive charges. So minus q plus capital Q. Hmm? That is given like this formula, right? So then the idea is that what changes, charge enclosed changes or not. So according to this idea, Gauss law in medium, charge, there is some induction happens in there. So total charge, now if you consider charge is made up of two, one is this charge q is called free charge, and that charge which is on the dielectric, which is induced charge, that is called bound charge. You should note that the induced charge is called bound charge, and this q is called free charge. Okay, so what happens now? The charge that is enclosed in that medium, that charge you have to consider the free charge plus the bound charge. So what happens now if you do that? So bound is induced, which is minus q 1 minus 1 by k. So this gives us rise to this, q by k. So what happens is that q enclosed, which was previously q, changes as q by k. So Gauss law actually does not change right hand side. The only thing that happens is charge enclosed. We have to take charge enclosed is nothing but the total charge enclosed. Now the total charge enclosed include the free charge as well as the bound charge in a dielectric. So this formula or this is not going to change. Still the charge enclosed is there, but charge enclosed changes, that is different thing. But Gauss law does not change in different medium. Gauss law remains the same, fundamentally same. But some people say that no, this epsilon naught become k times epsilon, although the effect is same. But we do not say that Gauss law is changing different medium, right? This is one point to note that. So when you are going to write this, this concept can be written in a different way also. We can write this different way. So the total charge which is induced can be also written as E times k. That factor, that is called displacement factor. Here they have given that capital D factor. Capital D factor dot area factor is equal to Q, which is free. This charge is the free charge. You can write Q or you can write this as free charge. Okay, free charge. So this is the formula of Gauss law in any other medium also. Here D factor is nothing but the um, displacement uh, displacement field vector. This D factor is called displacement field vector. Displacement field vector. Okay, this D vector is called displacement field vector. So what is the displacement field vector? Basically, if medium is not there, then epsilon naught into E. That is what it is. Epsilon naught into E. That is what it is. Okay. But if some medium happens, then in that case, that k times will be coming here, and then some calculations are there. And this idea is generally not discussed more. In advance, it is discussed. Okay. So this question, you can say this question is of advanced level, not for main level. Okay, but it is a theoretical question, right? So more detail about this dielectric, no, the same like in magnetism, we have susceptibility, we have all those factors. Same way here also in a dielectric, we have those polarization concepts and that thing. In NCERT briefly it is mentioned. You can refer to that. Let us move to the next question. So here, what will be the answer for this question? They are saying, if you see the statement here, Gauss law in a medium depends on the permittivity of the medium, right? So permittivity doesn't depend because charge enclosed change. So we don't consider that due to medium epsilon naught changes. That itself is wrong. So first is not correct. The electric flux through a closed surface depend only on the free charge. So that is what is free charge. So free charge, is this. So based on that only we are calculating that. Then what happens? Through a closed surface depends only on the free charge enclosed. What about the second one? Is it correct or not? Charge, see, charge enclosed, Gauss law depends charge enclosed. Charge enclosed include both free and bound. So we cannot say that only depends on free charge, because here this calculation is giving the total charge which is coming free charge by K. So Q enclosed it doesn't depend only on free charge. In a dielectric medium, it depends on free plus bound. In a vacuum, it depends only on free charge. That's the idea. So basically we can say it depends on charge enclosed. So second statement is also not completely correct. Then third one, polarization of a dielectric produces bound charges which contribute to the net enclosed. Yes, this is right. Third is definitely correct. Fourth one is also correct. Third and fourth are correct. So here, second, third, fourth. What about second? Let's check. Electric flux through a closed surface depend only on the free charge enclosed. Enclosed free charge. Charge enclosed here is the sum of free plus bound, and then it is coming on the free charge. I think we can consider this factor, because when you consider the total charge enclosed, this charge enclosed depend on free charge. Of course, here this factor K is coming, which is medium dependence. The electric flux through a closed surface depends only on the free charge enclosed. Free charge enclosed. So here you can see that the bound charge is not coming, although we are adding free plus bound. Free plus bound is giving us this, but it will also depend on this. Okay, I think this option we need to modify. This option number 2 cannot be 100% correct. It depends on free, but bound also it depends. Net enclosed charge it depends. So free charge enclosed, we cannot consider it correct, because enclosed may be made up of bound as well as free. Okay, so second, I think this option is not properly correct. So we should have only third and fourth options are correct. Second cannot be taken completely as correct. Okay, so we'll change the key for this. Let us go to the next question, number 5. Under space inversion r vector to minus r vector, which of the following remains unchanged? So electric field, magnetic field angular momentum, electric field linear momentum, torque and displacement. Definitely if you are changing displacement vector, then things will change. So fourth cannot remain unchanged. Linear momentum and electric field. What about linear momentum? P vector. Linear momentum is mass into velocity. Velocity is dr by dt. So R if we changing, momentum also will change. So this cannot be correct. What about electric field and magnetic field? Angular momentum. What about angular momentum? Angular momentum is R cross P. So note that if R you change, this will become minus and P is also becoming minus. So minus minus will become plus. So angular momentum does not change, that is correct. But what about magnetic field? Magnetic field. Magnetic field depends on what? Think about think about some formula related with magnetic field. Think where displacement vector comes. Can we think of Biot-Savart law? dB factor mu naught I mu naught by 4 pi I dl cross r factor by r cube. Let us think in terms of this. Suppose current carrying wire is there, it is producing that. So if I change uh, r factor is taken as minus r factor. So what happened to this? Cross products are involved, but what about this ideal vector? Will it change or not change? R vector if I change cross product here, yeah, of course it will change. So which formula should we consider here? That's also important thing to note, because some formula is there where R vector change can affect or not affect it, right? But definitely angular momentum is not getting affected. So that term is coming, but magnetic field we need to check. And what about electric field? One thing is that E cross B vector is parallel to velocity of light, right? Magnetic field vector, how do we calculate that? Is there any direct formula to calculate magnetic field? Because for a charge we can calculate. Suppose there is charge q, so at this place r factor, the electric field will be kq by r square into r cap. R cap is this direction. If you reverse that r cap direction, then it will change. Electric field vector definitely will also change. Magnetic field vector, how do we say that? Magnetic field vector, if you also define in the same way analogy of this, then this magnetic field vector also must change, right? Is there any other way where we define magnetic field? One is by Biot-Savart law, we say, right? Biot-Savart law, dl cross r. If you change r vector and if you change dl also, then you can consider same effect can happen, right? Suppose this is the direction of the current in this wire and this is the position r factor. So if this dl factor also changes, that means it become like this and this also become like this, right? R vector means it will become minus of dl and this will become like dl vector, this is minus dl vector, this is minus r vector. Then also same effect can happen. Maybe we have to take like that, otherwise magnetic field we cannot include in that. Angular momentum definitely is there. So right now we can go by this here, dl also changing, r vector also changes, so the effect of both changes neutralizes that. It's like in angular momentum, change of both neutralizes that. Okay, so let us go to the next question, question number 6. Monochromatic light source of wavelength. Wavelength is given 600 nanometer. Power is given 3 milliwatt. Right? Number of photons per second. So what is power? Number into energy, total energy by time. So N by T can be directly calculated as P by E. Power is given 3 into 10 to the power minus 3. Energy you have to calculate. Hc by lambda you can use that, or energy can also be, you can calculate Hc by lambda. Calculate that. Hmm. or in electron volt also you can do, but let's calculate that. 6.64 into 10 to the power minus 34, 3 into 10 to the power 8 divided by 600 nanometer 10 to the power minus 9. Calculate this. So how much it is? If I take nearly 1.1, this one into 3, 10 to the power, this will become minus 7, 15. So 15 minus 34, nearly 3.3 into 10 to the power minus. So that will become 9. Correct? Now if I substitute this 3.3 into 10 to the power minus 19 here, that is nearly how much? So it will become, if I remove, so 10 by 11 factor 10 to the power 19 minus 3, 16 will come. Correct? Now check the order. I think we need to check the order of that. So this will come as one order you take. Let us say 100 by 11 if I take. So 10 to the power 15. And note that here some approximation we have made. This we have got little bit larger than 1.1 it will come. Larger than 1.1 means larger than 3.3. So what order can we take? This will become anyway larger than 5. So I think this will also contribute a factor of 10. Okay, so 10 to the power 16 you can take. Order we need to calculate, right? Let us go to the next. Question number 7. In the given diamond network, all resistors are RRR. Batteries connected points C and D. Right? Like this. Resistor between A and C is increased by 20%. To restore the condition, VA by BV, distance between B and D should be. So note that this resistor, which is R, 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 R. Okay. This is C, this is B, A, D. So this resistor is changing. How much it is changing? By 20%. So zero point 0.2, that means 1.2 R it is becoming. So then this ratio, this by this will become right smaller, right? Previously this ratio was 1, now this ratio is 1 by 1.2. So this ratio also should be same way. Now this, now let us take that this has become R dash. Okay, so this R dash by R ratio should become 1 by 1.2. So R dash should become R by 1.2. Definitely it must decrease. Now how much it is decrease? So the decrease that has happened here is from R to R by 1.2 divided by R into 100. Calculate this. This is percentage decrease. Percentage decrease you can calculate. So RR will get cancelled. 0.2 divided by 1.2 into 100. This is 100 by, this got cancelled. 2 by 6. 100 by 6. 100 by 6 is how much? Take out this. 50 by 50 by 3. 3 how much? 1, 16. 16.67 percentage. Correct. That is the percentage decrease. Second option. Let us move to the next question. Question number 9. Question number 9 is what? A uniform circular disc. These are standard type of questions, right? Like this. And what they say, from a disc of capital radius mass capital M, rotating about an axis in its plane. So the axis is in the plane of the disc. This is the axis. Okay. passing through its center. Okay, small circular part of radius r by 2. So this is the center of that. This r by 2 is removed. Okay, original disk. Find the moment of inertia of remaining part of the disk about the same axis. So first of all, note that this mass is capital M for the bigger mass. Bigger mass is capital M. This is smaller mass. Mass is smaller is how much? Because its radius is half and it is a disk. Disk is proportional to area, so radius is square. So radius is square 1 by 2. Square means 1 by 4. So this is M by 4. This is M by 4 you have removed, right? So now find the moment of inertia of remaining part of the disk about the same axis. So first we need to note that what is the moment of inertia about this diameter. For the bigger disk, I of the bigger will be what? Mr square, Mr square by 2, not 2, by 4, right? Mr square by 4 about the diameter. For this is the for bigger one, and similarly I for the smaller one about the diameter itself is M smaller one. Its radius is what? R by 2 whole square by 4. So now you need to subtract that. Okay, subtract that. So I big minus I small. Calculate how much it is coming. So this is becoming mr square by 4 minus here m small is how much? M small is m by 4. So m by 4, this is r square 2 square 4 by 4. So check out mr square by 4, you can take common, right? So 1 minus 1 by 16 factor is coming. So what is the answer finally? Mr square by 4, 15 by 16. So 15 by 64 mr square. This should be the answer. 15 by 64. Answer is not matching. Let's once read the question again. Uniform circular disk of radius r mass capital M is rotating about an axis in its plane and passing through center of mass. A small circular part radius r by 2 is removed from the original disk as shown. Find the moment of inertia of the remaining part of the disk about the same axis. About the same axis means the same axis which is in the plane. So for the disk it is mr square by 4 only, correct? And that also mr square by 4. So m of small will become, because it is proportional to the area, so radius square, so 1 by 4, this is correct only, right? Radius has become r by 2 square, 1 by 4. I think that is the answer. Key change will be there for this. Okay, so the answer will be 15 by 64. That is the correct answer. Okay, let us move to the next. Maybe if they ask perpendicular axis, then answer may be different. If you want, you check for perpendicular axis also. Check for perpendicular axis. Suppose the axis is this perpendicular axis. Then in that case, for perpendicular axis, here I big will be mr square by 2. Okay, and what about I small now? About this axis only you need to calculate. So about this axis it is mr square. So I for a small about that axis you calculate. So mass is m by 4, m into radius is r by 2 square. So mr square by 2, that is about this axis. Now you need to translate this about this axis, parallel axis theorem. So plus this mass into this r by 2 whole square you have to do. So check out this, how much it will come. So mr square, and this is 4 into 2 32, it will come, plus mr square, and this is 16. So this becomes mr square by 32, and that will become 3, right? Now if I calculate about this axis for the remaining one, so I can use this mr square by 2 minus 3 by 32 mr square. Okay, so check about this calculation now. 32 factor will come, and here 16 minus 3 13. I think the key which is given is for this case perpendicular axis if you take. So whatever, I think most of you have done correctly only. Option 4 is not the correct one. Third option is correct. Okay, let us move to the next. Question number 10. Block of mass 3 kg is connected to a flywheel of mass 3 kg. So this is a flywheel and block is connected like this. This is also 3 kg. This is also 3 kg. Right? Some strings will be there. Angular momentum of the block about the center of mass of the flywheel when the block descends by 30 meters. Suppose this block descends by 30 meters. That time it must have gained some velocity, right? So we need to calculate the uh, angular momentum of the block. So angular momentum is mv into our radius is also given. How much is radius? Radius is 5 meters. So first we need to calculate the acceleration. If you can find out this acceleration, then we can calculate velocity. How to calculate the acceleration? Simple formula you apply here. Tension will be there, mg will be acting downward, mass is 3. So 3g minus tension is 3 into a. First equation. Second equation, this torque is happening here, right? T into radius. So torque, which is T into radius, is I into alpha. Torque, tension, radius is how much? Radius is 5. I is how much? I, it's like a disc, right? What type of flywheel should we take as disc? I think we can consider flywheel as a disc. So this moment of inertia is m r square by 2, right, into alpha. Alpha can be written as a by r. A by r. So from here calculate. Now this 5 also goes away, right? So tension will become 3a by 2. Second equation substituted back here. So 3g minus, no, substitute here, 3g minus 3a by 2 is equal to 3a. So from here 3a by 2 plus 3a is equal to 3g. 3 factor can be cancelled, so it will become 3a by 2 is g. So acceleration become 2 by 3g. Once you got acceleration, v is equal to v square equal to u square plus 2 is u is anyway 0. So use root under 2 a into distance x. So root under 2 into 2g by 3 into distance x. X is 30. So from here 3 10 10 10 10 will come out, 2 2 2 20, it will come 20 meters per second, correct? So once you got velocity, angular momentum, we can write mvr. So mass is 3, velocity is 20, radius is 5. So how much? 300. SI unit 300, first option correct. Is there any other way? Maybe by energy conservation you can also solve, because by the time it comes down, it will also get some kinetic energy, and this will also get some kinetic energy. So try to apply energy conservation concept. If I applied mgh, so 3 into g into height, which is 30, converts into kinetic energy half m into v square plus rotational kinetic energy half moment of inertia I. So I is m r square by 2, correct? Half I omega square. Omega square is what? Omega is v by r, so v square by radius square. Check this. Is this a better approach? Check this. This factor can be cancelled also. This become 300, and here v square by 2 and v square by v square by 4. So v square by 2. So 3 by 4 v square. So 400. Yes, this is a better approach, I think. Energy concept will give fast calculation you can do by energy concept. Okay, let us move next. Question number 11. Time taken by the block to reach to the bottom is, so this block is sliding over inclined plane angle theta, this length is L. So what is this distance? This distance is L by cos theta, correct? Find the time taken by the block to reach to the bottom. The wedge is given a vertical acceleration. Oh, the wedge is given a vertical acceleration upward. So now you can study this block from this frame of reference. From this wedge frame of reference, you study that. What will you see? That this block will have acceleration of force G is this direction. Pseudo force or pseudo acceleration is this way. So effective acceleration becomes G plus A. It is just like a lift which is going up. Okay. So the effective G which you consider G plus A, and this direction component is G plus A sine theta. Sine theta. So they are asking the time. Time is equal to root under 2 times distance. Distance is L by cos theta. By acceleration is G plus A sine theta. Correct. Just check, this is the option. So this becomes root under 2L G plus A sine theta cos theta. Okay. G plus A sine theta cos theta. If you want in terms of sine 2 theta, then multiply 2. This will become 4. So 2 will come out. L by G plus A sine 2 theta. Okay. Good question. This is recently modified question. Okay. Then second option. Let us move to the next. Next question is question number 12. A metallic with square cross section is heated to 1 degree Celsius. Young's modulus of elasticity of metal is JEE coefficient. Compressional forces. So see, note that here many of you have made mistake you have made. Very almost many people will make mistake in that. 99% will make mistake. So when you are heating it, first of all, original length is, let us say, L. When you heat it, there is expansion happens, right? This is delta L, you can say. So this final length is L plus delta L. Delta L you can write. Delta L is what? Original length alpha delta T. Now note that they want no elongation. So when it comes here, you start applying a force. This is the compressive force they are talking about. Compressive force. So compressive force will be applied at the final length. That final length will become like a original length, and then you compress it back to this position. You compress it back and bring it here, right? So by compression, you will putting a change of length as delta L. So this delta L is FL by AY. FL by AY. But here you note that this length which you are taking, this length is the final length, because you are starting compression from the final position and bringing it to the original length. So for mechanical, compression, you have to take the initial length as L plus delta L. Now you calculate delta L, you can substitute here FL by AY. Sorry, this is FL by AY. So delta L is L alpha delta T, and this is L. Here you can write delta L also. So L can be taken out, 1 plus alpha delta T, right, by AY. So this will get cancelled. So force they are asking here, force is AY alpha delta T divided by 1 plus alpha delta T, and you can bring it in the numerator by binomial expansion. So F become ay alpha delta t 1 minus alpha delta t. Note here that they have given in the question this delta t is t degrees Celsius, or which is also 1 degree Celsius. So you can substitute delta t as either small t or 1, right? So if you go with option, uh, check out the option, which option is correct here. Force only they are asking, right? So you will be getting the third option as correct. So check out about this. Third option will come as correct, not the second one. I think second is not correct. Okay, right. Let us move to the next question. Question number 13. Question number 13, three persons are there. So this is like 40 kg and this is like 50 kg and this is like 60 kg. And there is a plank. Plank mass is 90 kg. Note that this is A, this is B, and this is C. A is interchanging and C is interchanging. A and C are interchanging their position. They are asking, and note that B is not moving. B is together with the plank. So this whole plank will displace because delta x center of mass is equal to 0. You know that. Momentum conservation. So you can apply m1 delta x1. Suppose so it is 40. 40 delta x1 plus, here this total mass can be combined together because they are not moving. So 50 plus 90 can be taken as 140. Correct? Delta x2 plus 60 delta x3. This is equal to 0. We have this equation. Now they are also saying that, they are also saying one more thing. What is that? That A is coming this, so relative displacement of 1 with respect to 3 is plus how much? This distance is 2, 2. So this is plus 4. So from here delta x1 minus delta x3 is equal to 4. So delta x1 can be written as 4 plus delta x3. Correct? No, we need to consider displacement of first, second with third. Uh, Third is displacing, right? With respect to second, it is displacement of first with respect to second, it is. Okay. So displacement of first with respect to second, this is plus 4. So delta x1 minus delta x2 is 4. So delta x1 I can write as 4 plus delta x2. Similarly, displacement of third with respect to second is minus 4. So displacement of x3 is equal to minus 4 plus delta x2. So this and this we can substitute here and calculate delta x2. So 40 4 plus delta x2 plus 140 delta x2 plus 60 into minus 4 plus delta x2 is equal to 0. So check out this. 40 into 4 minus 240 minus 240 plus, so plus 80, 80 will come this side, and this 40 plus 60 100 101 240 delta x2. So delta x2 will give as 1 by 3. It is coming as positive, means towards right side. Towards right side it will know. So second option is correct, right? Let us move to the next question, number 14. Question number 14, you see. This is the second string, first string. This distance is L by 4. Center of mass mg will be acting here. This is tension T2. Here tension T1. But they are saying that we are going to cut this string 1. Okay. So tension in string 2. They are asking this tension after you are cutting it. After cutting string 1. How will you calculate this? So you can study about center of mass. Note that always try to study about center of mass, so that calculation, pseudo torque will not come. Okay, pseudo torque calculation will not come. So about center of mass, this T2, this T2 will try to rotate, and this distance is also L by 4. So torque created due to T2 into L by 4. This is the torque about center. And torque is I into alpha, so about the middle point. So M L square by 12 I into alpha. Alpha can be written as A by R. This distance is L by 4. So check out from here calculations. So this 4 into 3, this L gone, this L also gone. So acceleration can be written as T2 times 3 by 4. M will also come. Okay, so once you got acceleration, now write this net force. So mg minus T2 is mass into acceleration. So mg is equal to T2 plus mass into acceleration. Mass into acceleration, you can write mass into acceleration. What is mass into acceleration? Mass into acceleration will become 3 by 4 times T2. So mg is equal to 7 by 4 T2. So T2 becomes 4 by 7 mg. Okay, that's the answer. Second, let us move to the next. Question number 15. Displacement of a free falling body from rest in viscous. So viscous, right? Initially it is 0, then finally it will attain a terminal velocity, terminal velocity. Terminal velocity is constant. So velocity will become constant, means slope of the graph will become a straight line. So out of this, you can only figure out the option D, because the fourth option, right? Because here what will happen, this graph will become like this. After that it will become constant. This slope will become constant. This is what you have to note. That will happen after some time, long time, right? That's the only thing. Next, let us go to question number 16. So they are saying that in a vessel like this, there is a liquid, and this is the axis. You can consider this as origin, this as x-axis, this as y-axis. What is the equation of this? Any point you can take x comma y, and it is being rotated with the angular velocity omega. What is the equation shape? Equation of the vertical cross section. How to calculate that? Good question. Very fundamental question it is. Let us try this. So note that if you consider here due to this height, there will be a pressure here. What will be pressure here? Here you can take atmospheric pressure P naught. Here you will take P naught plus, and this height is y. So rho g h, which is y. So now this pressure difference, now you can consider a column here like this. Very, very thin column. Now for this thin column, there is a pressure difference happening, right? Here pressure is P naught plus rho gy. Here pressure is P naught into P naught only. But if you can multiply the small area here dA, and that area also you multiply dA, so we can calculate a net force in this direction. That net force will be rho gy into dA. This net force will produce a centripetal force. So rho gy dA, that centripetal force is mass of this element, m omega square into radius. Radius of this element will lie exactly in between. So this radius will be x by 2. Okay. So now let us write this. Rho gy dA. Mass is density into volume. That volume is length x into area dA, and this is omega square x by 2. So this dA factor will get cancelled, rho will get cancelled, right? So y, g into y becomes omega square x square by 2. So y becomes omega square x square by 2, 2g, correct? This will be the equation, omega square x square by 2g. That's the correct answer, right? Let us move to the next question, number 17. 10-meter deep lake, the bottom is at a constant temperature. So suppose some lake is there, 10-meter. Bottom temperature is for that we know in the lake. The air temperature is at minus 4 degrees Celsius. So here minus 4 degrees Celsius temperature is there outside. Thermal conductivity of ice is 3 times. Neglecting the expansion of water and freezing, maximum thickness of ice. Suppose some thickness of ice is getting formed here. That thickness you can take as x. So this thickness, which is water, that will become 10 minus x. Okay. Then what? Then apply the idea. Question is maximum thickness we have to calculate. 3 times conductivity. Suppose this conductivity is K, then this conductivity is 3K. Right? Here temperature is 4 degrees Celsius. Here you can take 0 degrees Celsius and then minus 4 degrees Celsius. Okay. Then what? So note here one thing, whatever the rate of flow of heat, this is like series. The current is going to be same. Current means dq by dt. So let us write the equation of dq by dt here in water. Dq by dt will be what? K. Of course minus is there, but we can ignore that. So K into area of cross section, whatever area will be there, by thickness, which is here 10 minus x, into the temperature difference from here to here, which is 4 on, and this from here to here is how much? 3K. Area is same, thickness is x, temperature difference from here to here is also 4 on, correct? So now find out Ka 4 4. So x is equal to 30 minus 3x. So 4x is equal to 30. So x is equal to 7.5 meter. Correct? Here the mistake can happen in drawing the diagram. In drawing the diagram, you may think this has 10 and then above you take, but above you don't have to take, because from whatever layer 10 meters, from there freezing will start. Correct? The answer should be less than 10, not more than 10. Okay. Let us go to the next question, number 18. What is the equivalent capacitance? Two resistors are there. One capacitance is there. There is another capacitance is there. Another capacitance is there. This is point A. This is point B. Value of resistance 2 ohm, 4 ohm, 6 microfarad, and this is 6 microfarad, this is 3 microfarad. They are asking equivalent capacitance between A and B. Note that if you connect a battery so that they will become fully charged, and after that you disconnect the battery, they will not be able to store charge. Why? Because they will dissipate the heat energy, because they may get charged till the time you are connecting it with the battery, but after you disconnect a battery, what happens? This is like a discharging RC circuit, so it will lose all its charge, so it will not be able to hold any charge. So we can take the capacitance C equivalent is 0. Technical question, no calculation is needed. Okay, let's go next. Question number 19. Find the magnitude of work done. A to B electric field is given. Work done given. Work done in moving charge. So what is the work done? It's charge into potential difference. Charge into potential difference. So potential difference, let us calculate. Minus E factor dot dr. We can do integration, right? Let us calculate this. Electric field they have given x square plus y square power minus half. Sorry, x square y cube it is. Square y cube power minus half to x I cap plus 3y square j cap. Dot product with dr. Dr is what? Dx I cap dy j cap. So dot product with dx I cap dy j cap. Do that. So this will become, of course, minus. If you want minus, you bring this side. Then this integration x square plus y cube power minus half, and this become 2x dx plus 3y square dy. Now note that if I substitute this as z if I substitute, right? So z or some other variable take t per power minus half, then this factor will become dt. Note that because x square differentiation 2x dx y cube 3y square dy, so that will become dt directly. So this calculation will become little bit simplified. So 1 by root, right? So you can multiply 2 to numerator. So 1 by 2 root, that means root 2. So root t will be that. Now you can substitute it back. So root under t was what? T is x square plus y cube. Now you put the limit from where to where? 0, 0, 0, 0, 0, 0 to 1, 1, 1. Substitute. So root 2. Right, magnitude, let us take magnitude of delta v. So substitute work done. Charge is how much? Charge is 1 coulomb, and this is 2 root 2, right, volt. So that's what it is, 2 root 2. This is the answer in joule SI unit. Correct, option 3. Next, let us go to the next question. Question number 20. Question number 20, big question, looks like a story, but now need to get confused. Okay. So there is a neutral metal ball of mass and radius given, right? Insulating horizontal surface they have given. Electric field is acting upward direction. Some electric field is there. Okay. Stream of light ions. Some ions are going to hit it, right? Ions are moving. So ions are moving here. So some positive ions you can consider like this. So these ions are moving and going to get deposited over its surface. So over this entire surface, so area of this beam you can take as pi into r square. Okay, r here is already given, so 4 by pi it will become, so 4 meter square. Area of the beam is 4 pi r square, and it is going with some speed it is going. So that speed it is given, and density is also given, charge density. So try to find out current here, how much current will be coming. What is the question is that friction is sufficient so that it cannot move here and there. Time in which it will get lifted up. So when it will get lifted up, let us say that it develops a charge. So due to that, charge into E and mg, it will just get lifted up when QE become mg, right? So QE become mg. So what is Q? Current you need to calculate. So note that this density is charge per meter cube, right? Multiply with area into velocity, because area is what? Meter, velocity is area is meter square, velocity is meter per second. So meter cube will get cancelled, it will charge per second. So this is the idea by which you can calculate current. So let us calculate current first. Current will be how much? These density values let us substitute. So 5 into 10 to the power minus 12. right? Area already 4 we have calculated. Velocity they have given 2 into 10 to the power 6. So how much this comes? 10. So 4 into 10 to the power minus 6 and then 10 power minus 5, right? Now this charge can be written as current into time. Current into time into E is equal to mg. So time will be mg by IE. Now substitute mass is how much? 50 kg. G let us take as 10. Current already we calculated 4 into 10 power minus 5. And electric field they have given 5 into 10 to the power 5. So this power's gone. 5 for 20, right? So how much it is? Check out that. So this is 500 by 5 for 20. So 25, 25. So the correct answer is 25. Little bit lengthy in reading, but after that, once you understand calculation, it will be easy. Okay, let us go next. Now, section 2, we are going to numerical part. Question number 21. What is the question? Read that. This is last year question. Okay. The bob of mass m is suspended like this in a length L left to perform vertical circular motion initially by applying horizontal velocity v naught at point A. String becomes slacks, right? Hmm. That means speed at the bottom is like the minimum speed root 5 gr. Okay. Now the speed at A is reduced by n times. So now previously some speed was there root 5 gr. Now we are putting a lesser speed. Previously it was root under 5 gr. Now we are putting this speed. Let us take this speed as v1. Okay. Now it is going somewhere. Where it is going? It is going here, where this angle is 60 degree. Okay. And they are saying here also symmetric point you take, and this point is B and this point is C. Okay, the question is the ratio of kinetic energy bomb at B and C. The ratio of kinetic energy. Suppose here speed is V2 and here speed is V3. Definitely, because this is going to be equilateral triangle 60 60 60. So this radius is also, this height is also equal to radius only, correct? Radius only. You can just think between here and, because they are not asking to calculate energy. You have to just think of here and here energy conservation apply. So what we need to calculate is at B kinetic energy, that is half mv2 square by half mv3 square. And note that here tension is 0 they are saying. That means v2 by v3 whole square we need to calculate. Okay, so here to here energy conservation apply. So V3 square is equal to V2 square minus 2g into height. Height is R, right? So V3 square you are getting. This relation you are getting. Okay. This relation we are getting. Anything else? And note that here tension is going to be 0 means the only force is going to be mg. Mg of course this direction. Then this side component. You can take the component g itself if you want, because at this point this is mg. If you want you can take mg. This angle is also 60, so mg by 2, mg cos, this mg by 2 is centripetal force, mv square, v is v3, mv square by radius. So from here v3 square becomes gr by 2. Once you got this, substitute here, v2 square will become gr by 2 plus 2 gr. So they become 5 by 2 gr, right? Now you take this ratio, v2 square by v3 square. So v2 square is how much? 5 by 2 gr, and v3 square is half gr. So that becomes 5 is to 1. So this ratio is 5 is to 1. So that answer there will be 5, right? Next, question number 22. Particle is projected 30 degree from horizontal with speed 60 meter per second. So with 60 meter per second at an angle of how much? 30 degree. projected. Height transfers by the particle in the first second h naught and height. So you know that it is going to be a projectile motion like this. So so here they are saying the first second time 0 time 1. This height is traveled is h naught. Then next they are saying the last 2 seconds before it reaches maximum height. So first of all, figure out how much time it takes, time of ascent. Time of ascent is u by g, u vertical direction. So vertical direction, what is the speed? Component 60 by 2 sine, right? So 30. So 30 by g, if I take 10, so 3 seconds. So 3 seconds, so 1 second already it is over. Next 2 seconds it will be reaching here. So that this height is h1, the next 2 seconds. So we need to find out ratio of h0 by h1. Calculate. First calculate h0. So vertical speed is how much? 30. So ut minus half g t square. Calculate 25. Right. Now let us calculate. So while you can calculate upward or downward, same thing will happen. Downward you calculate it is better. So h1 is equal to half gt square. Time is 2 square. How much it is? 20. That's all. Over. So this is how much? 25 by 20. So 5 by 4. That's the answer. 5 by 4. Next go for 23. Force vector is given. Okay. Path is given. So there is a force vector f vector x square y I cap plus y square j cap, and particle is going along this path or this plane. Work done from 0 0 to 4 2. Work done. So work done will be integration of force dot dr factor, right? Dr is dx dy, so x square y dx plus y square dy. This integration we have to do. Also note that this path is the given, so you can try to transform it. Y can be written as tan minus x. So you can break this x square into tan minus x dx, and this is anyway y square dy. Do this integration. So tan x square integration x cube by 3 minus x cube x4 by 4. X is going from where to where? 0 to 4. Plus y square is y cube by 3. Y is going from where to where? 0 to 2. Substitute and calculate. So 10 by 3, 4 cube minus, this will also become 4 cube, right? Then this one 2 cube by 3. 4 cube you can take common. 10 by 3 minus 1, 7 by 3 plus 2 cube 8 by 3. Take LCM 3. 4 4 4. Calculate. If you still want, you can take LCM. 4 4 4, 64 into 7 plus 8. Correct. Calculate, take 8 LCM if you want. So 8 into 7, 56 plus 1, 57. So 8 by 3 into 57. This will cancel by 19. Correct. So check the answer, 152. Correct. Then let us move to the next. Question number 24. A string of length L is fixed at one end and it is going like this. So this is like a conical pendulum type of problem. This radius is r they have given. Length is L, angle is theta. Some tension is given. So a string of length L is fixed to one end and carries a mass m at other end. Okay. The mass makes 3 by pi rotation per second. So frequency is given. Frequency is 3 by pi. So omega is 2 pi into frequency. Substitute 6, it will come, right? Then what they are asking, passing through one in the tension. Tension we need to calculate tension. So this mg will be acting like this. This angle theta will be there. So tension cos theta, tension sin theta. Theta value they have not given. So tension sin theta is nothing but m omega square radius. Tension cos theta is equal to mg. We know this. We need to calculate tension in terms of m and l. Okay. So this is the radius. This is length. Radius can be written as radius. What can we write? Tension is not given. You can take ratios, I think. Ratios we can take. Tension we need to calculate. So only one of them you can use. Let us use this one. Sin theta is what from here? Sin theta is perpendicular by hypotenuse, so R by L. M omega square is 6 square into radius. Radius cancel, tension is 36 ml. This is the answer, 36. Okay, let us move last question. So let's take the last question, question number 25. The position vectors of two particles are there, point A and point B. Their positions are given. Let us write the position. Values also let us write is alpha 1, alpha 2, alpha 3 they have given. So t square. Second one alpha 2t. Alpha 2 is 3n. So 3nt. Then alpha 3t. Alpha 3 is 2. So 2t. And particle B position is minus 1 minus t. Then beta 2 t square 4p t square, right? And beta 2, so beta 2 is minus 1, so minus t square, right? And beta 3 4p 4pt 4pt. They are saying that the magnitude of velocity at 1 second, velocity A and velocity B magnitudes are equal, right? And they are also saying that this dot product is going to be 0 because they are orthogonals. Then also they are asking at 1 second only, they are asking what? They are asking torque acting on particle A with respect to particle B. This magnitude they are asking. That is the whole question, right? So now let us try to first calculate velocity. Velocity will differentiate 2t, 3 and 2. Even accelerations can be calculated. So this is velocity, right? And velocity vector, and acceleration vector will be what? 2 0 0. Similarly from here calculate velocity vector, minus 1 minus 2t 4p. Calculate acceleration vector, so 0 minus 2 0, because p and n are constant. So once you got this, now first calculate magnitude of velocities are equal. So here at 1 second, note that at 1 second. So here root under 2 square plus 3n whole square plus 2 square. This is going to be equal to velocity of B at 1 second only. So root under this is going to be 1 square plus this also become 2 square plus 4p whole square. Check out these values once again. Is it constant? Is that everything correct or not? Beta 2 is minus 1, beta 1 is how much? Beta 1 is 2. I think I made mistake here. This is 2. This is beta 1 is 2t and this is minus t square. Okay, so its differentiation will become 2, right? Here the differentiation become 2 minus 2t and 4p. Okay, anyway, now it is correct. Now you check that. I think this is 2 square. This is also 2 square. So from here 2 square get cancelled. Then you can say 3n is equal to plus minus 4p. 3n is equal to plus minus 4p. Okay, after this what to do? Also dot product. Dot product also you check dot product. So 2 into 2 4 plus 3n 3n into minus 2, so minus 6n, right? Minus 6n plus 8p is equal to 0. So from here we can say that 3n is equal to 4p plus 2, correct? Check out this, 3n is equal to 4p plus 2. Now 3n, if 3n is plus 4p, then 2 will be equal to 0. That is not possible. So 3n has to be minus 4p. So minus 4p is equal to 4p plus 2. So 8p is minus 2 or 4p is minus 1. 4p is minus 1. If 4p is minus 1, what will be 3n? Because 3n is minus 4p. So 3n will be plus 1. Okay, so once you got the value of 3n and 4p, then we can think about this calculation of torque. So calculation of torque will require what? Calculation of torque requires forces, right? So how do you calculate forces or accelerations? Accelerations we can clearly see here that the acceleration of the first body is 2 and acceleration of second body is minus 2, but the coordinates are different, right? There is different coordinate. It is in x coordinate, this is in y coordinate. So let us try to understand this very clearly. Suppose if you are seeing this particle A, right? This particle A and particle B. So mass is how much? 1 kg. Mass is 1 kg. So acceleration first is along this x direction to, right, acceleration, and acceleration of B is minus 2, but it is in this direction, in this direction. If you want, you can write this also. If you want, you can write acceleration of A as vector as 2 I cap and acceleration of B vector as minus 2 j cap, right? This is at 1 second. Now you have to also study the forces or torque. So when you are studying relative to A, that means, are you studying relative to A? No, you are studying relative to B. So you have to calculate A relative to B. So observer is B here. B will give his negative acceleration. So this acceleration is downward. So opposite acceleration means 2 will come here. So acceleration of A with respect to acceleration, yes, acceleration of A with respect to B will be 2 I cap plus 2 j cap. So because of this, you can say that this is like a pseudo acceleration. So what will be the force that will be acting on A with respect to B? That is the total force from this, that force will be what? Mass is 1 anyway, so 2 I cap plus 2 j cap. This is the force, net force. This resultant force is relative to B. Now once you apply that, the concept of pseudo torque is also coming, because if you don't take this pseudo force, pseudo torque, you cannot calculate. Now you calculate net torque A with respect to B. So I cap, j cap, A cap, R vector. R vector is what? R vector also you need to calculate. You need to calculate R of A with respect to B. That means RA minus RB. So what is RA, RB? Just check that. Initial position of RA. What is RA position? At 1 second, correct? At 1 second only. So position here 1, 3 and 2. 1, 3 and 2. Position of A is 1, 3 and 2. 1, 3 and 2 minus position of B. What is position of B? Check position of B. Position of B here 2 minus 1, 2 minus 1, 4p. 2 minus 1, 4p. This is 2 minus 1, 4p. Now 4p value we can substitute. So this is 1, 3n is 1. This is 2 minus 2 minus 1, 4p minus 1. Now you calculate, subtract this minus this. Okay, so when you subtract 1 minus 2, so minus 1 I cap, and then this 1 minus minus plus 2 j cap, 2 minus plus 3 k cap. This is what it is. So here minus 1 2 3, you have to write minus 1 2 3, and force component is 2 2 0. Let us now calculate this. Calculate. So I cap, how much? 2 into 0 0, minus 3 into 2 6, minus j cap, how much? J cap, how much? Minus 1 into 0, minus 3 into 2 6, plus k cap, how much? Minus 1 into 2, minus 2, minus 2 into 2 4. So check out how much it is coming. It is coming minus 6 I cap plus 6 j cap minus 6 k cap. All the coordinates are 6 6 6, right? Now magnitude, let us calculate magnitude. Magnitude is going to be root under 6 square 6 square 6 square, right? So how much? 3 times 6 square, root under, you have to calculate root under only. Okay, so 3 into 36. So how much it is going to be? 6 into 3 18, right? 6 into 3 18, 1 then 9 1 10, 108, 108. So the correct answer will be root of 108. I think the key is given as 208. By mistake we will correct the key and we will re-evaluate the marks of those who have attempted this paper, right? So thank you all for your attention. I hope you got this, and you can see the questions are quite tricky, and certainly some shift of the JEE main questions are tricky and difficult. Some of the questions are JEE advanced level questions also, so you have to be prepared enough. At the same time, you don't have to panic. Whatever you have prepared, that is sufficient. You have to be just confident, you have to be calm and cool, and you have to maintain your focus. Don't get panic and don't get nervous or disturbed due to the exam stress and exam environment. If you can remain calm and cool during the exam, and proper management of time if you do, and all the three subjects you balance, definitely you will come out with a flying color. So thank you all for your attention, and hope all the best to all of the students writing this, right? Thank you.